So in this lecture we will start unit number 2, and we will talk about some features of power supply to the domestic consumers. Domestic consumers, you must know, are regular consumers like you and me. There is another category of consumers which are known as commercial consumers. So commercial consumers are industries, factories, institutes. So they are in the category of commercial consumers, but domestic consumers are normal people like you and me. So the first thing that the supplier of the electricity has to agree to give is that the voltage, that is the voltage that of the voltage that is of the power of the electricity that is supplied, that it must be within plus minus of 5% of the standard voltage. So it is, if the standard voltage it's 220 volts, within the 5% plus minus 5% plus minus 5% voltage of this 220 volts, this has to be given by the supplier. The frequency is in the range of 1 plus minus 1% only. And there's another term known as total harmonic distortion. This is not in the scope of this course, but nevertheless it's a very important criteria. The supply should be present all the time, and voltage fluctuations. By fluctuations we mean that if the voltage is supposed to be 220 volts, it must be this voltage at almost all times. It should not fall down to, let's say, 110 volts or 120 volts, or voltages below standard ratings. Now, some safety measures that can be incorporated in our daily lives, which can prevent electrocutions and home fires. So as you know that electricity is a very useful tool, but at the same time it has some dangers as well if not used properly. So some of the safety measures that can be used are: you can have to make sure that all metallic parts of the electrical equipment, they are effectively earthed. By earth we mean that there has to be a proper every house, every building must have a proper connection to the earth. I will come to this in a bit. So the second measure is that any broken switches or plugs which can lead to sparking, these should be avoided. You should always make use of a tester to test whether a terminal is live or not. This linear tester is a simple screwdriver. It has a flat end. It is usually yellow in color. It has a bulb inside. So this can be used to check whether the terminal is live or not. Whenever you want to make whenever there's has to be some repair, etc., to be done, you have to make sure that the supply is to be turned off. Also, never use equipment or appliances with damaged wires which are exposed or wires which are cut, because you see that conductors, copper wires, they are usually, the copper is inside and it usually has an insulation outside. This insulation you can touch, but you have to ensure that there is no cut in the insulation like this. So in this case, if you touch this point, you will get this electric current, which is very dangerous. So you should avoid this. Also, you have to make sure never to use bare wires in the holes for taking a connection. You have to always use a proper plug. So if there is a socket somewhere, don't use bare wires in these. Always use a proper plug. And when you are repairing or testing equipment, you have to ensure that you use rubber sole shoes so that your body is not in direct contact with the earth. And lastly, you have to use gloves when you are dealing with any live terminals. Some more precautions and precautionary practices that can be used: always make sure you use insulated tools, and never touch two different terminals at the same time, because in this case what happens, is that your body acts as a conductor, and this gives the current a free path, very little resistance. So the current will flow through the body, and this can be very dangerous as well. For your domestic use, you have to ensure that you are using the MCB. MCB is the miniature circuit breaker. So you have to ensure that you use a MCB of proper rating. Similarly, when you are repairing any electrical appliances, you have to ensure that the plug is taken out from the socket, and never connect machines to the voltage supply that are not the rated voltages. So if you have a volt machine which is rated at, let's say, 115 volts, do not connect it to a 230 volt supply. So you have to be sure about this as well. And whatever machines or devices you are using, there are always precautions and instructions given, so make sure you follow those instructions and letter and stuff. One of the major reasons of fire hazards are overloads, because of overload, what happens is that when the system is when the wires are overloaded, they get heated up. So because of this heating, the insulation melts, and when this insulation melts, the wire becomes a bare conductor, and it can lead to catastrophic damages. So this should be avoided at all costs. And wherever you are using appliances, you should always ensure that you always check for damaged plugs, switches and cords. And whenever you are connecting devices or plugs or sockets, you should ensure that the connections are proper and tight. So these are some of the precautions that can be used by domestic consumers to prevent any fire hazards or electrical short circuits. Now, as I mentioned earlier, there is this concept of earthing. Earthing, as you must be aware, has earth in it. So what is done in case of appliances is that you see there is a earth wire. Earth wire is provided in all major appliances. So if you have a socket, you would have seen the socket looks something like this. The topmost circle is usually bigger than the other two, and your appliance a 3-pin plug goes into this. So this is actually the earth terminal. So everywhere, all of these terminals have to be connected together, and this has to be connected to a pit known as the earth pit inside every household, every building, so that any faulty current that occurs in this appliance, all of this current goes directly into this earth wire, and then it goes into the earth pit without causing any damage to the other building or the house or whatever the case may be. So this is to ensure that this is a very important safety measure, and it is recommended that every household and every building be earthed properly based on the recommendations of technical based on advice of electrical engineers. So if you ask why is this earthing needed, it is needed to ensure the safety of life and property of from the hazards of electrical shocks and fires, to ensure that the system voltage on the healthy lines remains within reasonable limits, to provide a low impedance path for the current to flow, and whenever lightning occurs, this lightning discharge can be directed towards this earth wire without damaging the rest of the electrical fitting. So what is earthing? It is defined as the process of connecting the metallic frame, that is the non-current carrying part of the electrical equipment, to the earth. you can skip this part. This is the general definition, but I don't this is not important to you. So the non-current carrying part of the devices, they are connected to the earth by means of process known as earthing or grounding. So what happens in this process? You connect the non-carrying metal parts. Let's say you have a device, let's say you have an oven at home which has a metallic body. So you want to connect this body, which is a non-current carrying body, you want to connect this body to the earth. So this is basically what they simply stated. This is the basic concept of having earth connection. It does not affect the day-to-day functioning of the circuit, but it prevents unnecessary fire hazards or dangerous situations of insulation breakdown or short circuits, etc. So if you see, this is the simple diagram showing any device. This is the device that I was talking about. So if this is your main supply and this is the circuit, so this dotted is your device which you are using. This device has a metallic body. So if you don't earth this device, this device inside has some machinery inside, let's say a motor denoted by this letter M. So this motor and this body may be connected or may not be connected. There may be some resistance Re. This resistance, some resistance may be present. So if you happen to touch the body of this device when the device is functioning normally, nothing will happen. The device is operating normally, you touch the outer body of the device, so nothing is going to happen. What happens if the insulation becomes faulty? What does this insulation mean? This means that if this Re breaks down, if it becomes very, very less, may happen due to various reasons. If this this resistance becomes very, very less, what is going to happen? The current from this M motor, that current is going to flow into the outer part or the outer body. So when I touch about this metallic body, I have, let's say my body also has some resistance Rb. So what happens? The current gets a path to flow. What is this path? This path is this device, this resistance Re, the resistance Rb, your resistance or my resistance. So current gets a complete path to flow, and all of the current will flow through Re first and U later. So what happens? There is this leakage current which is known as IL known as the leakage current. So it could become dangerously high and may cause a lot of damage. So this is why you should not use ungrounded devices or ungrounded enclosures. Okay. So the second category is a case where you connect the metallic body to the return path, to the return neutral. This is again, if you have a earth supply coming to your home, you can simply connect the metallic body to the neutral of the of your supply, and this automatically grounds the supply. Grounds the body. So even if you touch it, no current will flow, because the current will take this path. And in case there is some current in the external body, it will flow through this part, and this will not lead to any insulation breakdown, or eventually it will not lead to any shocks, etc. So the third and the most effective method of using this scheme would be to connect your equipment or your device separately to the ground. So what you can do is, if you have a house, it has 10 rooms, the earth wire can be made to pass through the entire circuit of the house, and so wherever you are connecting a device, simply just plug it in properly, so that the exterior or the metal body of this device gets in contact with this earth wire, and the equipment is earth, so everybody can be safe and this equipment can be used safely. So if you see these equipment, they usually have a green colored wire. So this green colored wire is the ground wire. If you see, there are three colors: red, green and blue. Sorry, black. Red, green and black. So this green G is the ground wire. Okay. So electrically, these outlets, if you see at your homes as well, outlets or sockets, they have three terminal device. So this is the live wire, this is the neutral, and this is the ground connection. Okay, normally in old houses, or in if you see, take a look around your house, you may or may not have earthing. So for those of you who are are constructing new houses, or want to construct a house later, or want to stay somewhere, if you have the chance, you should go for this earthing, for the overall safety and well-being of everybody around. Okay, so this is all about earthing. So generally, it is believed that currents below this range of 5 milliampere, they are not dangerous. So even if you are in touch with a little amount of current, let's say 5 amperes or low, it is said to be not dangerous. If the current is between 10 to 20 milliampere, what happens if you touch this current source? You may lose muscular control. So an important important parameter that you should keep in mind is that the resistance of the human body, normal human body, between the two hands or between one hand and leg, it's about 500 to 50 kilo ohms. Okay, so if the resistance of the human body is said to be 20 kilo ohms, and if it comes into contact with a 230 volt line, what will be the value of the current? It is so much so that it can be potentially fatal, and it may lead to death. So Brunner, this scientist, 1967, he has given this threshold that the perception of electric shock is seen when the current is about 1 milliamperes. At 1 milliampere, you will notice a shock, or a shock, tingling sensation. So this is the criteria. The threshold is 1 milliamperes. So when the current increases, this sensation of tingling leads to contraction of muscles. So when muscles in your body contract, what happens? You are not able to move, and when you are not able to move, you are not able to let go of you cannot release the grip of the conductor. So as they say in Kashmiri, power of lagun. So what is power of lagun? Basically, you get in touch with the conductor, your muscles contract, and you are not able to let go of the grip. So this is very, 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 very dangerous. So you should always take care while dealing with electrical equipment and electrical supplies, because when you lose muscle action, you are fixed. God forbid, it may lead to death. It may lead to burn injuries, or it may lead to death. The maximum current at which the person is still capable of releasing a conductor when it comes into its contact is known as the let go current. So this let go current is that current. If you are in touch with this amount of current, if you feel this much of current, if you are in contact with this much current, you can safely let go of the conductor. You will just feel a shock, you will move your hand away and you will be saved. This current is about 9 milliamperes for males and about 6 milliamperes for females. So above this current, let's say for 10 milliamperes for males and say 7 milliamperes for females, this current will lead to loss of muscle activity, and which may be catastrophic at the end. So different types of earthings. There are a number of types of earthings. There is pipe earthing, there is plate earthing, and there is strip earthing and rod earthing. So I will give you this PDF. I will mail this PDF to you, the PDF of these slides. So you go through this PDF at your own places. You go through this lecture as well once again, and you read about these different types of earthings, and try to understand how this earthing actually works. And then we will move on to the next lecture of this series and the next lecture of this unit. So I will see you in the next lecture.